You're ready.
Okay. Hello, my name is Nash F, and today I'll be presenting my AP research project focused on attrition in engineering and the role of self-efficacy in high school students. So before I get started, I'd like to give some preliminary background information on the project. And so when I graduate following this academic year, I'm going to pursue a career in education in aerospace engineering. And so because this is a year-long course, it was important for me to focus the project on something important to me and personal so that I would stay engaged. So that was engineering. And as I was discovering the literature of engineering, I saw videos online on the notoriety of engineering, that being how difficult the subject is. And so I came across attrition, and so what is attrition? Well, attrition is the action or process of gradually reducing the strength or effectiveness of someone or something through an external pressure. And so to simplify this, this is just an external pressure that slowly weakens someone. And so this is important because attrition causes desertion. And according to the Journal of Engineering Education, 1 in 4 students attrit from their engineering program by their first year. And so understanding what these pressures are is key to understanding what attrition is and how we can stop it. So some of these external pressures are student-teacher engagement, which is how well connected a student is with their teacher. Better relationships with the student and their teacher will lead to better academic performance. There's also the classroom environment. So STEM classrooms are often perceived as more cold and uninviting compared to the humanities. And so there's also self-efficacy, which I'll delve more into just a minute. Efficacy is the ability to produce a desired or intended result. So self-efficacy is one sense of self to produce a desired or intended result. And this idea is basically just self-confidence. And so in the context of my research, the assumption is made that self-efficacy is related to experience because presumably the more experience you have, the more self-efficacy you will have. The International Journal of STEM Education performed a study on university makerspaces with students. A university makerspace, if you didn't know, is just a small room with some 3D printers or other machines that students can use to build and create things on their own. And what they found is that when the students engaged with these makerspaces, they had increased levels of self-efficacy when it came to building and creating things. So if you were, let's say, an engineering student taking classes and other extracurriculars, you would have more experience and therefore more self-efficacy. And this is why so many careers value experience, because as we gain more experience, we gain confidence in our own abilities. So now we know what attrition is and the importance of self-efficacy, we can find where experience is obtained. And so the assumption is made that experience primarily comes from college and high school. And that's because in college, students can take extracurriculars and other classes, and the same is true for high school. However, high school doesn't cater learning to specific interests, and instead covers a variety of subjects across multiple areas, And so, on top of the fact that there are many prerequisites for engineering programs, I decided to focus the research on high school students. Not only is there a gap in the literature, there isn't a lot of information on high school students, there is also a higher indicator of a student's self-efficacy in high school, because this is where students will pursue their interests and decide when they want to become engineers. So if they take more classes now and gain more experience, they'll have a higher self-efficacy going into their first year of college. And so another factor I looked at was the location of a school. And so urban schools in a large city will have more students, and then that usually means they have more funding. And also being in a larger city, you have more access to tech companies and other opportunities that students can pursue. And rural schools are more remote, farther away from such opportunities. And since STEM is expensive and they have less students, they may have less funding to afford these STEM opportunities. And of course, there are exceptions to this fact, like if you're a charter school, you may have tuition and that can afford these sort of things. However, this is generally the case. And so I focused the research on Southwestern Randolph High School because it is a rural school and one I attend myself. And this led me to ask the two questions. To what extent does a rural school limit the experience of students pursuing engineering? And how does this affect the attrition they could experience in college? And so this brings us to my hypothesis, where I'm hypothesizing that rural high schools won't have ample opportunities for students because they have less funding, and therefore the students would have less self-efficacy. And this brings us to the methodology section. And so to answer this, I performed interviews, and that's because you may have heard about NC Parent Bill 49, Item 11 prevents the mass collection of surveys without parental consent. And if I had to distribute parental consent forms to 50 students so I could get a wide variety of information, it would have been really difficult to try and get all those back and then send out surveys. So interviews were the next best thing, and that meant I could still collect my quantitative and qualitative data. And so qualitative data is important because it's subjective and it's based on the quality of the responses. And so I was able to ask questions like, what is your favorite classes? What are 3 words you use to describe engineering? And quantitative data is more factual, physical responses, and that is more objective. Excuse me. And so, sorry. This brings us to the sampling. And so the nature of the research meant that random sampling was not needed. And so random sampling ensures that responses are candid and not skewed whatsoever. However, I needed students with opportunities and who were also interested in engineering, because that's what the research pertains to. And this meant that only 5 students were interviewed, seniors at Southwestern Randolph High School, interested in engineering and also happened to be in the AP research class. And this type of sampling is called convenience sampling, because you interview students who are at the convenience to you, who are closest. And so not using random sampling actually benefited the research because I was able to interview students who actually pursued experiences for STEM and then see all the opportunities that a rural school like Southwestern Randolph High School could offer. And so I also didn't interview freshmen or other underclassmen because they might change their interests over time, and ultimately seniors have had the most opportunities to take opportunities. Sorry, okay. So the questions were designed in such a way where I could see the type of student, how ambitious they are and how they might seek opportunities in the future, and I could also see a brief overview of all the experiences they have had. So this is why questions like asking about their course history, GPA, SAT score, and other college-related questions were asked, because I could see how they might have pursued, or how they might, pursue engineering in the future, and how many experiences they have now. And this brings us to the results section. And so here you'll see all the quantitative data. At the bottom are all the test scores for ACT Math, ACT Science, SAT Math scores. And you'll see that majority of the students didn't remember their test scores at the time of the interview. However, I'll point out how all their unweighted GPAs are above a 3.7 and their weighted GPAs are above a 4.3, which would mean they are high achieving at Southwestern Randolph High School. Here is the responses to the 3 words to describe engineering question I asked them. And I highlighted some of the things I'll talk about later. In blue you can see math, in purple are things related to creativity, and then in red are things related to how difficult engineering is. Here are the college-related questions. So I asked them what their college major is that they want to pursue, their reason for pursuing engineering, and then the desired degree they want. All their engineering topics, fields cover different areas. So it's there's a wide variety of interests. And then there were 3 reasons for why they could pursue engineering: a desire for salary, a desire for knowledge, and a desire to grade. If you wanted to be an engineer for monetary reasons, that would indicate a desire for salary. If they wanted to be an engineer because they enjoy learning and they want to have the knowledge of engineering, that would indicate a desire for knowledge. And if they want to learn how to build and create things on their own, that would indicate a desire to create. And the fact that there are no desire for salary is good, because that would indicate a higher level of self-efficacy, because they have an intrinsic desire to be an engineer rather than some physical reason. And here is a brief version of my course history, because the actual version is 3 times longer and I wanted to show something. And so all the students have taken Math 1 through 3, AP Pre-Calculus, and Biology. And the majority have also taken AP Calculus, AP Computer Science Principles, and Chemistry. And this is good because this meets the majority of engineering prerequisites, with the exception of physics. And with that in mind, we can now go to the analysis section. The first thing I analyzed was academic performance of all the participants, because if you knew what kind of student they were and the classes they'd taken in the past, you could see the experiences they have had. And so all the participants are high achieving, like I said, with mostly A's and B's in a few of their classes. And so they also all meet prerequisites for the majority of engineering programs, with the exception of, like I said, physics. And that could be due to the fact of availability. I've only been here for a year, so I don't know if the school like offers it every year, but there is that fact. And physics is also considered difficult. It's an upper level math class, so that could be a reason. And then participants 1, 3, and 4 have taken some specialist classes like engineering technologies, hardware software support, and AP stats. And this increased experience would indicate a higher level of self-efficacy because more experience leads to higher self-efficacy. And they have also gone out of their way to take more difficult classes and therefore more experience and more commitment. And this brings us to something I want to point out. And right now, the class of 2026 is unable to take AP Calculus, and that's because there aren't enough students interested in taking the class. It would just not be beneficial. And the reason why I'm pointing this out is because Southwestern Randolph High School offers community college classes that students can take online or North Carolina Virtual Public School. And this allows students to still seek opportunities outside of school and gain the experience they want. However, students who aren't as committed to engineering or their interests may not pursue these other opportunities to take the classes they need, which will filter out some students. So sometimes this can be a good thing, and sometimes it can be a bad thing if the students aren't willing enough to pursue. And this leads us to the second thing I analyzed, which is probable ambition. And that's what I've been talking about at the beginning, because self-efficacy is what leads to, self-efficacy is caused by gaining experiences, and what causes self-efficacy is the student's probable ambition. I said that wrong, but it's okay, yeah. And so, probable ambition is how willing or invested a student is in engineering, and that can help determine how they might seek opportunities in the future. And so, higher course load would mean more experience, and a longer degree desired would indicate more commitment. So the combination of these two would lead to a higher self-efficacy. So participants 1 and 4 both indicated they want to pursue their master's degrees and then also have more experience. And so that means they have a higher probable ambition, which means in the future, if they feel attrition, it's likely that they could still seek opportunities and more experiences to not feel attrition. And then this brings us to the third thing I looked at, which was the words used to describe engineering. And so the main categories I decided were math, creativity, and difficulty. And so math is pivotal to engineering. It's how you actually solve the problems. And then creativity is how you think of the solutions to the problems. And then difficulty. And so I started the project on the presumption that engineering is difficult. So the fact that these students also think that engineering is difficult, or at least associate the idea that engineering is difficult, would mean that when they do feel attrition in the future, they may not be surprised or actually desert their program because they know what to expect. On top of this, all the students said that math and science were their favorite subjects, which means they enjoy the subject, and so they acknowledge the fact that it is hard in the first place. And so the implications of this are that some rural schools have opportunities and some don't, right? So we are fortunate in Randolph County to have opportunities like Randolph Community College or North Carolina Virtual Public School, whereas some states and some rural schools in those states may not have a virtual public school available and may not have a community college nearby that they can attend to supplement their education, and just funding, they may not have access to computers. And so this does refute the hypothesis, however, that I had initially, where I thought that rural schools wouldn't have ample opportunities, because as you can see at Southwestern Randolph High School, the students did have the opportunities they needed to pursue engineering. The deciding factor was the students' probable ambition and not a lack of the school itself. And this also meant the research didn't go without limitations, because I did interviews, the sample size was much smaller, and I would have liked to have gained more interviews, but there were just not enough students I could find that were interested in engineering. And this just means that I can't generalize the information from the results too much, because I could have gotten lucky with my sample that said what it said. And so another limitation was time. If this was a much longer course, maybe covering like a research project over 2 years, it would have been a lot easier to collect all the surveys, parental consent forms, instead of like the 3-month window we had to collect data. And so in the future, I would advise a longitudinal study that focuses on the opportunities of students and their interests over time, and see how opportunities might change over time. For instance, right, the class of 2026 can't take AP Calculus next year. Will that affect how students might want to pursue STEM education or a desired degree program in the future? And also, I would survey multiple grade levels, because then you can see how the grade levels have changed over time with those opportunities as well. And in conclusion, rural schools do offer opportunities, and it ultimately comes down to the student's probable ambition to pursue their interests and their goals. Thank you.
All right, good job. So if you will listen as Mr. Hodgins starts with your questions.
So how did you determine which results that were generated by your research method were most important in informing your new understanding?
So yeah, there was, so when I performed these interviews, I tried to, I made like a net, you could say, of like multiple questions, and a lot of stuff I omitted from the research because they didn't, I was trying to, as I went through the research process, I realized that probable ambition was more important than I initially realized. And so I looked at things more closely, like the college-related questions, because I realized that was more vital to what led to more experiences and therefore self-efficacy, and then solving attrition. And so a lot of things like, I asked the students if their engineering program was ABET accredited. I didn't use that at all because it just wasn't really relevant. That would have been more related to if they knew that ABET accreditation was important, and it wasn't like, I didn't end up using it in my research.
Thank you.
What are the real-world implications or consequences related to your findings?
So as I mentioned before, rural schools often do provide the opportunities that students need to pursue engineering. But just because they don't have funding, it doesn't mean that students can't find the opportunities they need. We often see that a lot of people will go out of their way to, if they really want what they want, they will pursue the opportunities no matter how hard it is. And so ultimately, it's not an issue of are rural schools good enough, it's an issue of are students willing to pursue their interest and what they want to do.
Okay, if you could revisit your research process, what would you do differently and why?
I think if I could redo the research process, I would have adjusted my questions to focus more on probable ambition instead of having all the questions about like the ABET accreditation. And that way I could have gathered more relevant information to my research process instead of omitting like half of my interviews.